Hello. For our introductory biology course with Dr. Sata, we chose to interview Marcus Ho. Marcus works for Landscape Services within the University of Texas at Austin and played an instrumental role in the automation of the university's irrigation systems.
So, for first question, we're just going to go over some background information. So we're wondering, where did you go to school? What did you study? And
Yeah. All right. I went to school at the University of Texas in Arlington.
Okay.
I started off as a CSE major and realized I didn't want to program for the rest of my life, so I switched over to information systems.
Gotcha.
What led to the job you're working today?
So I have a passion for water conservation. And back in 2011, UT switched their irrigation system over to a central irrigation system, a lot more management and detailed. I was actually the contractor that installed it. Once they get done putting this new system in, they realized they needed someone to manage it and asked me for it. And I just wanted to be a part of the system, loved what was put in and the objectives for it, so I was all on board and wanted to be a part of it.
And when was that?
2012 is when I first started.
Gotcha.
So did you ever think that when you were a college student you'd be in the job you are right now?
Not at all. Actually, I thought I'd be in the CIA, not working for a university. I love programming, I thought. It was great until I programmed 40 hours a week and I realized I don't want to keep it up. I love the way data works with different aspects, and I want to get an aspect of that and be able to see what I can do with it. Think outside the box. Also, getting in a little bit with the drones, wanting to see future capabilities of it. At the last I was dealing with the drones before in the middle of college, it was mainly used for warfare. How can we integrate that into civilian life? And now, since I've been out of college, there's been a huge move in that direction where we can start utilizing.
And what classes helped you the most in deciding what you wanted to do? And did you get any involved in any research in a college campus?
No research in the college campus, but a lot of my programming classes actually connected here in some aerospace engineering classes. I looked at drones back when I had a customer line that I was managing. They're, managed a company that did drones over in Iraq and Afghanistan. So it got me interested in that, and some of the aerospace classes kind of connected the dots with it. So I saw a lot of possibilities back then in college with drones in the future applications.
So how long have you been working at the Irrigation and Water Conservation Coordinator here at UT?
So I have been here since 2012, so this is my 7th year.
So what was it like when you first started, and how has the industry changed?
So when I first started, technology is not really used in irrigation a lot.
Mm-hmm.
You bring it up, most of the people in the field don't even have iPhones back when we first started. Now we're integrating so much technology, utilizing live weather data, drones, and other aspects. Where I go to conferences now and people all have tablets, smartphones. Technology is becoming more well-versed in the irrigation industry.
So on that note, what do you see any innovations for the future? Do you see any thing that could benefit you even more?
I do. I see integration more with moisture sensors and drones. Drones give us a good image of how healthy a turf is to see if we need to make changes or any diseases or anything else going on. So I see a lot more integration in new technologies that are coming out. Internet of Things. More communication between the systems in the field and people that are managing them.
Gotcha. So since you first started working at UT, what have you improved on?
So I've integrated more with the students. I've had several different groups of students come on, different classes and professors that I share information with, integrating their classroom work with what we're doing on the campus. I have a project going on with 4 students right now at LBJ utilizing drones in a concept that they're working, that they actually just started a business on the outside in agriculture using what we're doing working together. So I've improved a lot on working with students and trying to get what you're doing in the classroom with actually hands-on work in the field.
What advice do you have for students who are trying to conserve more water on the campus and just be more green?
The biggest thing is being self-conscious of what's going on and what you're doing. If you're in the shower and you're taking a long shower, realize every drop of that water that's going down the drain is fresh drinking water. And in 2011, when we had the drought and everything was down, we're at 30% water. Every drop counts. And it's a big factor when you're going through. The bottle refillers, using those, different things that we're doing on campus to be more water conscious and sustainable, utilizing those. This is UT. We make a big difference in Austin. And every drop matters so much, especially when you have over 50,000 students here. It's a lot of people, a lot of water, a lot of flushing toilets.
So when Austin underwent the water shortage in October, last October, how was the UT's like landscapes impacted by that?
What was nice for us is that we were going into the off season, so it wasn't a large impact as it would have been during the summertime. What we did immediately is we shut down all outdoor watering. So anything out there, we contacted the city, let them know immediately, we're shutting everything off, shutting down all the fountains. That way we didn't impact the shortage of the water. We knew that they were limited on how much water they can filtrate and clean. We didn't want to be someone that was pulling off that just water landscape that was going into dormancy. So what was nice when it was coming out is we were in the off season by that time. It was almost November, everything was to the stage where it doesn't need water for over the winter time, so we've just left everything off. It actually helped UT save a lot of money.
So how has technology transformed your career? It's a big part of what you do.
It has transformed it quite a bit. Instead of being in the field digging ditches and digging holes, fixing things and trying to troubleshoot, now we're getting alerts on our telephone letting us know when a break happens, where it's located. We now have iPads where we can have plans of the irrigation system. So we'll get an alert of we have an issue, we have a plan, we know exactly where to go, and then we can use our iPhone or iPad to turn on that zone to look and see what's happening. Huge difference in what we used to do before.
Definitely.
Sending two guys out into the field, one to run the controller, one to look for it, and try to find out where that call was coming from. Very inefficient.
So I have a quick question. So I know you said that you did some programming classes in college, and then you switched to information studies, right? But have you have those like programming classes come into handy like in your job?
They have. So I
Yeah.
took C++ was my major programming language that I had. I now use a program called Tableau. And some of the stuff in programming behind the scenes, I guess maybe my calculus helped me a lot more with the formulas that I'm having to use within the program, trying to visualize some of the data sets, and then also integrating different programs to communicate. I pull data out of one database and put it into another program myself. I didn't ask the vendor to do it. I figured out how to do that by thinking outside the box and saying, okay, I learned this in school. I can create this program to get this to work for me.
Oh, so like a pipeline kind of.
Exactly.
Yeah. Okay. Because I'm interested in like CS and stuff, so it's interesting to hear like that and.
Well, a lot of the technologies and softwares that we have out there can be modified or combining different data sets to be able to pull that information out of. And a lot of people don't see that as a whole. They see irrigation or building water usage. Well, those are data sets that are ones and zeros. We can bring those together and create visualizations and see where we need to cut back water or we're using too much water at using that information.
Can you talk specifically how you use drones in your everyday life?
Sure. So we are utilizing them with special cameras in DVI and NDRE, which looks at the plant chlorophyll that's being released and how green it is. So we'll fly it over a landscape and see, okay, the turf is stressed or not. If it's not stressed enough, I'll cut back water. I want it stressed, because if it's stressed, a lot of times it's going to grow its roots deeper, looking for more water. If it's too healthy, it's going to have shallow root system. So I want it stressed to a level. But then we also look at the trees. A lot of construction on campus, and our trees are a very valuable resource for us. We'll fly them before a project and throughout the project to see if any of the activities going on is stressing those trees out. But we're also looking at roofs, if we have leaks in roofs, 3D modeling of buildings, progress shots of buildings going in, and we're about to start a new process where I can actually superimpose the drone image in a AutoCAD file and make sure the measurements are lined up precisely with that building as it's being constructed.
So what additional equipment is needed like for your drones, and how does it work like in total, like everything?
So with the drones, additional that I need to purchase or?
Just like I guess cameras, or like what other equipment do you need to set I guess the whole thing up?
So
How does that sensor work with the chlorophyll?
So it looks at the light reflected. Everything has a wavelength. If you're looking at a color, it's got a wavelength coming back off the type of material it is. So it takes that information in and calculates that based on, I guess, it first started with hyperspectral cameras that looked at every wavelength, and they shortened that down to certain indexes that they learned actually showed plant health and what level they are. And that's what they created the NDVI, Normalized Differential Vegetation Index, I believe is what it's called. And that's what let us know the health of it. But any cameras coming up, we're looking at thermal, we're looking at basically larger size drones that can hold more payloads than just NDVI normal camera. Thermal, looking at the thermal image, infrared. That way we can see if we have a leak underground we never knew existed. So we have large pipes underneath UT that are 16, 32 inches in size and bigger. If they're having a leak that's 15 feet down, how do you know? It's so much water. But my goal is to use the infrared thermal imaging. As the water percolates up, it's going to cool off the soil around it. That way I can take a look as I fly it over and say, okay, we have a cool area off the pipe here. Your leak is in this area. Go digging for it. So trying to use that, but we're also working with students in this concept. We have an aerospace engineering department here. We have people that are flying drones that are about to be moving into the old Anahist gym. We want to integrate what they're working on with what we're doing so they can get hands-on and we can learn from what they're utilizing. It has taken me over 4.5 years to get UT approval to fly drones on the campus. And it has been a struggle getting it through and pushing, showing the usefulness of it. I've been able to present in front of the senior vice president, showcasing him the usefulness of it, but it's more showing the cost savings of it. I found out you can show someone great pictures, but if there's not a cost savings associated with it, they don't care. Well, with a roof, if we have a leak in a roof and they decide to replace the whole roof, it's about $1.5 to $1.8 million to replace a roof here on campus. People don't understand that. But if I fly with my drone and find out that it may not need to be replaced, or if there's a few issues that we can repair, it's around $40,000. So you go from $40,000 to $1.8 million at the max. It's kind of, the drones have improved quite a bit of the information there. But we're trying to find out different departments can utilize this. We're talking to School of Architecture. How can they use it as they do renderings of buildings? We work with different companies out there when they're planning a project. We'll fly an area and then they can overlay images on top of it, of what they want to have as the final image. So we try different ways of integrating more and more of the drones into what they're doing.
How many drones do you have?
So far I have 2. Technically I have 3. I brought my own. So UT is still looking at the funding, the different stuff. Office of Sustainability funded 1 drone with a special camera due to the student group wanting to test out some stuff, so we have that one. And then I brought my personal ones with me as well. So trying to showcase the usefulness of them and try to get UT to purchase them. We're in the process right now of looking at a higher level drone to start utilizing more on campus. I actually have 2 meetings this week to discuss that. We want to get a 30 zoom camera, so that way we can fly away from the power plant and take images of the buildings and stuff around it. They don't like me flying around the power plant with the drone. They're too concerned about it falling and crashing. The drone's about this big, and I'm thinking if it hits anything, it's going to break the drone and not. But they're overly cautious. So trying to get more higher level equipment. There's a professor here on campus who's doing a project for Department of Energy, looking at switchgrass. He's flying a large size drone with a hyperspectral camera. It's a $75,000 setup. So trying to get him to let me use that drone for a little bit to do some more mapping, seeing maybe possible issues with the streets. If we have an area where there's a different reflective, that could be a weak area in the street where we can repair before it becomes a pothole and someone on a little scooter or bicycle doesn't fall into it. So trying to be more proactive as we move forward.
So how much have you invested into the company?
So far, UT on drones has invested about $8,000. The central irrigation system to save water is $2.1 million. So it sounds like a lot, but we have a cost avoidance now over $1 million a year. We're saving around 125 million gallons of fresh water a year that we used to put out that we no longer. A reduction of 75% of our original water use. And we also put this out on the dashboard where people can go without a password and see exactly what we're doing, so that way complete transparency. First ones in the world to do that, and that's why we won an award in 2017 for the TCEQ for Texas Environmental Excellence Award. We actually got to go with President Fenves to the Capitol, meet the governor, and receive an award for the efforts.
So now that we have a broad understanding of what you do right now, we were wondering what's next?
So I'm always looking at different things to come in. Drone is one thing, but I'm looking for automated mowers. So basically, I want a mower on our satellite locations to go out and mow on its own, and then be able to see it with the drone if I need to keep an eye on it. That way we don't have to send personnel out there, waste time and money and gas, that the mower will do its job. But I'm also looking to integrate smaller size drones on each irrigation controller, so if there's a high flow break, the drone will go up, take pictures of that zone while it's running so we can see what the issue is before I even send a guy out to the field. So trying to think the next level, we're still probably 5-10 years off on that. We have to get the FAA approval that Amazon and everybody's working on, but once that gets cleared off, it opens up the world of opportunities, saving a lot of time, effort, and water out there.
Throughout all of this, what's been your favorite part of it?
I really like working with students. Y'all think of things outside the box, and I'm like, how did you get that idea? But I like working and having that different aspect. Seeing your new minds as you're going through new stuff that I wasn't going through in college, and bringing that to the forefront and saying, try this. I like that aspect. I like that freshness that's constantly coming through with each year, new students, new ideas, and then allowed to integrate those concepts into what we're actually doing.
So, what advice would you give to college students today in picking a career? Any questions you went through that you answered, you know?
Find something you have a passion for. Find something that you really want to be a part of and go for it. And look outside the box on what you're thinking. If you're in a certain school and department, most people don't look at the college you're at has so many opportunities when you graduate to come back and work for it. We have a legal department here. We have a project management, construction, facilities management. We have so many opportunities here that you can come work right now with before you go out in the real world to see if you really want to do that career path. And I think that a lot of students don't utilize that enough. Or if you want to come sit with a project manager for a week and see how he works on it, we have that available right now. We have a power plant here that's one of the most efficient in the world. Come utilize the resources here and help guide you in the right direction.
Working on this project, I've been able to learn about Marcus and his work here at UT, and it's helped me gain a better understanding of how technology is being integrated into new fields and about just how important water conservation is. As the program coordinator for irrigation and water conservation, Marcus has helped transform UT's irrigation system to be more sustainable and more efficient. Listening to Marcus talk about sustainability and what we as individuals can do to better conserve water made me reflect on my own habits and how I can change those for the better. As a student who is still trying to figure out what career I want to have, it was helpful to hear about Marcus's path to finding a career where he is able to both do something that he's passionate about and make a difference. Learning about how Marcus was able to use his computer science background in his work with irrigation really helped show that all learning is productive, and even if you don't end up having a career in a subject area that you've taken classes for, that knowledge can still be put to use.